Hi folks, we're going to take a look at number 4 from the extra review questions on Unit 5. Okay, so they give us this tide question, so let's just try to get all the basic information here. So high tide, so our maximum is going to be equal to 8.2. It's positive since it's above sea level. A bit of a typo here, I would say, since low tide is negative 0.6 meters, that would mean below sea level. Then I say below sea level again, so really that just means 0.6 below sea level. So a little typo there, so it should be just negative 0.6. Okay. So from here, we can calculate our A and our C values. In fact, let's do that right away. So A is equal to, so we have 8.2 minus negative 0.6 over 2. So that's 8.8 divided by 2 is 4.4. Here, C is equal to 8.2 plus negative 0.6 over 2. So that's 7.6. 8.2, 7.2 plus 4, 7.6 divided by 2, so 3.8. There we go, we got it. Now, let's take a look at our period here. So notice that they give us times from high tide to low tide. So that doesn't represent a full period, it only represents half the period. Okay, so we got to figure out here from 3:38 a.m. to 10:08 a.m. Okay, so 3:38, so 4:38, 5:38, 6:38, 7:38, 8:38, 9:38, 9 hours and then a half, so 9.5 times 2, so our period is 6.5 times 2 is 13. There we go. So that means that our K value is going to be equal to 2 pi over 13. All right, now we have to figure out our parent function and phase shift if needed. Okay, and so here again, you're going to see me use a little graph to help me out. So I noticed that we're starting at 12 a.m. on June 1st, and high tide occurs at 3:38 a.m. That's the one that occurs first. So I think that's what I'm going to use as my parent function. I'll use y equals cos x, which starts at the maximum, but I'm going to need a phase shift. So here, if I just draw this without a phase shift, so starting with, cos x, which starts at the maximum, but the maximum does not occur at 12 a.m., it occurs later on. So that means I have to move this function to the right by 3 hours and 38 minutes. But I don't want to work with hours and minutes. I'd like to work with decimals here. So essentially this means I have to move it by 3 hours and 38 sixtieths of a minute. Of an hour. So let's figure out what that is here. So what do we have? We've got 38 divided by 60 is 63333. So that's about 3.633. Okay, so that's going to be our phase shift. So now we're going to get our model here. So if you let x be time in hours from 12 a.m. June 1st. Okay, so we really should be defining our variables here, and y be height of water in meters with respect to sea level. All right, so there's our variables, and so now we can write down our equation. So y is going to be equal to, our a value is 4.4. We're using positive cosine. Our K value is 2 pi over 13, and we need a phase shift of 3.633 to the right. So that's going to be x minus 3.633, and then plus our C value, which is 3.8. All right, so there's our model. All right, now what we want to do is determine when the tide is at sea level. And so we essentially just need to make this equal to 0, because that's what sea level represents, is height of 0. Okay, now again, maybe another little typo here is this is actually going to look like a lot of answers from June 1st to July 31st, so I don't think I'm going to find all those answers. I guess I should have thought that through, given that my period is only 13 hours. Okay, so let's just see how we would find these answers. Okay, so now we're solving this equation here. So step number one, since this is actually a linear trigonometric equation, is just to isolate the trig ratio. So try not to get thrown off by the fact that that looks kind of ugly. I'm just trying to isolate this expression here. So we have cos x of this whole big ugly thing is going to be equal to, so bring the 3.8 to the other side, divide by 4.4, so it's negative 3.8 over 4.4. I'm not going to bother calculating that because I'm just going to put that in my calculator, and I can see very clearly this is not going to relate to a special angle. So I'm going to use my, oh, sorry, that should just be cos of this. Very poor form there. All right. I'm just going to have to use the inverse cosine. So the next step, so now that I've isolated my trig ratio, the next step is to find two values of cosine, which are two angles for which cosine is equal to this number here. So the first one will be, so we have 2 pi over 13 times x minus 3.633, okay, can be equal to, so the first one is just going to be given by inverse cosine. Okay, so inverse cosine, and since it's negative, I'm expecting something in the second quadrant, so bigger than 1.57. So inverse cosine of negative 3.8 divided by 4.4, okay, is equal to 2.61, okay, which is definitely in the second quadrant, all right, or the other answer is going to be 2 pi minus this value, and that should give me something in the third quadrant, which is also where cosine is negative. So here we have 6.28 minus 2.61, and that gives me 3.67, which is indeed in the third quadrant. All right, so let's keep this out here because the next step now is to solve for x. So x is equal to, and I'm going to do this all in one shot. So here, what do I have to do? 2.61 multiply by 13, divide by 2 pi, which I'll just use 6.28, and then I'm going to have to add 3.633, and that gives me, well, about 9. Okay. Or, and now I'm going to do the exact same thing with the 3.67. Okay, so 3.67 times 13, 13 divided by 2 pi plus 3.633, and that gives me 11.2. All right, so these are my initial answers, and now to determine other answers, I just have to keep adding the period, which is remember that the period was 13 hours, okay? So in this case here, and I'm not going to keep going, I'm just going to find a few of them. So, 9 plus 13 is 22, plus 13 is 35, plus 13 is 48, okay? And this is all in hours. Okay, and remember hours from 12 a.m. And same thing here, 11.2 plus 13 is 24.2 hours. Okay, plus 13, 37.2 hours. Plus 13, this will be the last one I do, 50.2 hours. Okay, and way too many to actually list from June 1st to July 31st. Okay, so I'll leave it at that. So let's just recap. So step number one was to come up with a model. Okay, remember that to find the parent function, look for some special feature that occurs near your starting point. In this case here, the maximum occurred near my starting point, so that's why I used a positive cosine, and then I just used a little graph to determine the phase shift. Once you have your model, you follow your algorithm for solving equations. Step one, isolate your trig ratio. Step two, determine your two answers using the inverse trig function and the particular related angle identity, in this case 2 pi minus theta, since we were working with cosine. Step three, solve for x for those two answers, and then step four, keep adding or subtracting the period to get the remaining answers. Okay, that's it for this.